Alright, so today we are going to talk about the momentum, one of the concepts that we find in physical sciences, particularly physics, paper 1, grade 12. So today I will be just doing the introduction, then later we will look into the examples and how do we calculate this momentum of an object. Before you can start, be aware that all physical quantities that we find in physics have symbols. Physical quantities, I'm referring to all properties of matter that can be quantified or measured, meaning that properties of matter that can be defined in terms of numbers. We can measure them, hence we can define them in terms of numbers. So momentum is one of those physical quantities. Hence the symbol for momentum is capital letter P with an arrow above it. Why did I put this arrow here? Is because momentum is a vector quantity. It has both magnitude and the direction, of which in most textbooks they don't put this arrow. Then we have another physical quantity, which is mass. The symbol for mass is small letter m, but there is no arrow here. Why? Because mass is a scalar quantity. It has only the magnitude. Then the third physical quantity is velocity. And the symbol for velocity is small letter v with an arrow above it. Why? Because velocity is a vector quantity. It has both magnitude and the direction. So in this case, we have three physical quantities. The first one, momentum. Second one, mass. And the third one, velocity. Momentum and velocity are vector quantities, while mass is a scalar quantity. Let's go to the definition of momentum. It says momentum is the product of mass and velocity of an object. We have three highlighted terms or words within our definition, and these terms or words will help us to understand the concept of momentum in detail. Let's talk about mass and velocity for now. Later we'll talk about the product. For an object to have momentum, firstly, it must have mass and it must move from one place to another. It must possess the velocity. Meaning that momentum depends on mass and the velocity of an object. If you don't have velocity, you won't have momentum. So meaning that objects that are stationary, that are not moving, they don't have momentum. They have zero velocity. Hence, they will have no momentum. Now, here on our definition, it says the product of mass and velocity. What do they mean by the product? Product means in mathematics, we multiply two or more variables or values. So this means if we multiply mass of an object with its velocity, we'll get the momentum of that particular object. Again, there is a relationship between momentum and these two physical quantities. Mass is the measure of the inertia of an object, of which I will talk about the relationship between the mass of an object and its inertia when we'll be talking about Newton's laws, particularly Newton's second law. Let's go to the velocity. Remember, I said to you, an object must move from one place to another. It must change position. It must be displaced in order for it to have momentum. And of course, it must have mass. So in this case, velocity is change in position of an object per unit time, or you can say velocity is the rate of change in position of an object. Okay, so hence here on the formula, V is equal to change in position of an object over change in time. And you can see here that the symbol for position indicates that position is a vector quantity. It has both magnitude and direction. Why? Because there is an arrow above the symbol. Okay, so the SI unit for velocity is meters per second. It's very important when you are doing your calculation, please give your answers or your numeric answers the SI units. So let's go back to the momentum. What is the formula for calculating momentum? We will get the formula from our definition. Again, our definition says momentum is the product of mass and the velocity, and I told you that the product means we multiply, meaning that if we multiply two variables, in this case mass and velocity, m and v, then we'll get momentum. Hence, the formula for calculating momentum is P is equals to mv. Then what are the SI unit for the momentum? The SI unit for the momentum is kilograms meters per second. How did they arrive to this SI unit? It's very simple. Let's go back to our formula for calculating momentum. You ask yourself, what is the SI unit for mass? The SI unit for mass is kilograms multiply by what is the SI unit for velocity? The SI unit for velocity is meters per second. So this is how we get the SI unit for the momentum. So in our video, we said we have two concepts that define momentum, and those concepts are mass and velocity. So the symbol for mass is small letter m, and the symbol for velocity is small letter v with an arrow above it. We said mass is a scalar quantity, and then velocity is a vector quantity. So mass, scalar quantity, meaning that it has only the magnitude. Velocity is a vector quantity, it has both magnitude and the direction. We said the SI unit for velocity is meters per second, and the SI unit for mass is kg. Now we said velocity can be calculated by using this formula: change in position of an object per unit time, or the rate of change in position of an object. We said the product of mass and velocity will give us momentum. And the symbol for momentum becomes P, capital letter P, with an arrow above it, because momentum is a vector quantity. It has both magnitude and the direction. So this means you are multiplying two variables, m and v, to get P is equals to mv. Now the SI unit for momentum, you are going to multiply kg with meters per second. Then it will result in kg multiplied by meters per second. So these are the SI unit for momentum. So here we have three cases based on the calculation of momentum. We're gonna look at the first case, then followed by the second case and the third case later. So you have 5 kg ball at its rest state, stationary, meaning that it's not moving. Its velocity is 0. When they say an object is at rest state or it is stationary, they mean like it's not moving. Its velocity is 0. So now the question says calculate the momentum of this particular 5 kg ball. So before you can attempt to answer the question, firstly, and this is the rule, firstly you state your direction. Why? Because momentum and velocity are vector quantities. They have both magnitude and their direction. That's why I say state your direction before you can start your working. So now you can say to the right we are talking about positive direction, and to the left we are talking about negative direction, or to the right negative direction and to the left positive direction. But I would like to refer to the left as positive direction. So now let's state our directions. So to the right we're gonna say it's positive direction, and to the left then we are talking about negative direction. Since we are calculating the momentum of this ball, then step number 3, this means we're gonna list or state the formula for calculating the momentum. Momentum equals to mass of an object multiplied by the velocity of that particular object. Then we substitute our values. So your mass is 5 kg multiplied by your velocity is 0. So 5 multiplied by 0 is 0. So our momentum is going to be, or the momentum of the ball is going to be 0 kilograms meters per second. And now let's look at the second case scenario. So now the 5 kg ball was kicked and it started to move with the velocity of 3 meters per second to the right, of course. Now calculate the momentum. So first step, you list the direction, or you state your direction. So we are going to say to the right we are talking about positive direction, and to the left we are talking about negative direction. That's the first step. Second step, you list data, the useful information from your scenario. So your mass equals to 5 kg, your velocity equals to positive 3 meters per second. Why positive 3 meters per second? Because velocity is a vector quantity. It has both magnitude and the direction. So it's going to be the direction and the magnitude. So our direction is positive and our magnitude is 3 meters per second. Step number 3, we'll state momentum formula. P is equals to mv. Then you list, you substitute your values. Then your mass is 5 kg multiplied by positive 3 meters per second, our velocity. Then 5 multiplied by 3, or positive 3, we get 15 kilograms meters per second. Now your final answer here, it is positive. So since it is positive, you're going to conclude, therefore the momentum of the ball is 15 kilograms meters per second to the right, or to the positive direction. Okay, along its way, this ball collided with the wall and it changed direction to the right, as it is indicated here. Now we are expected to calculate its momentum. So the first thing to do is to state the directions. So we are going to say to the right positive direction and to the left negative direction, or you can say to the right negative direction and to the left positive direction. Now, second step, we list the useful information that we're going to use to calculate the momentum of this ball. So it's going to be our mass equals to 5 kg, our velocity equals to negative 2 meters per second. Why negative 2 meters per second? Is because now the ball is going towards the negative direction. So velocity is a vector quantity, so this is the direction and the magnitude. And now here you can see that the velocity of the ball has decreased after the collision. I'm going to ask you the question, why did the velocity of the ball decrease? Third step, we state our momentum formula. P equals to mv. Then we put our values. Mass is 5 kg multiplied by our velocity is negative 2 meters per second. Then 5 multiplied by negative 2, we are going to get negative 10 kilograms meters per second. Now your momentum is, or your momentum value is negative, so you have to conclude, therefore momentum of the ball is 10 kilograms meters per second to the left or to the negative direction. When you state the directions, please be aware that you must ignore the signs. For an example, here we have been calculating the momentum of this ball. Then we found out that the momentum of this ball is negative 10 kilograms meters per second. Then I had to conclude, then I said, therefore the momentum of the ball is 10 kilograms meters per second to the left. Here I'm stating my direction using weights, hence I have ignored my sign or the sign. So that's the first thing you have to know or you have to do. When you're stating the directions of the vectors in weights, you ignore the signs. And again, always list your SI units, because if you just put negative 10, is it negative 10 degrees Celsius? Is it negative 10 kilograms? Or is it negative 10 kelvins? So that's why it is very important for you to state or to indicate your SI units always when you are doing your calculations.